What's going on, guys? In this video we are going to talk about homogeneous second order linear differential equations. The general pattern for the second order linear differential equation look like this. We have function of x, y double prime, another function of x, y prime, another function of x, y, and that's equal to another function of x. And when we talk about this kind of second order linear differential equations, we try to bring this into this pattern, like we only have the coefficient and y double prime, b y prime, and c y equal to 0. So when we equalize this one to 0, that's what we call homogeneous. Okay, then after that we take this as a corresponding function like this: ar square plus br plus c is equal to 0, and we look at the root, and if we get the root that is distinct, if we have different roots r1 r2, the general solution for the differential equation is going to look like this: y is equal to c1 e power r1x plus c2 e power r2x. And if you have repeated single roots, for example, if you get same values, you are going to have the general solution of the differential equation. That's going to be y is equal to c1 e power rx plus c2x e power rx, right? And if you get complex r1 r2, you will get the pattern like this: e power alpha x c1 cos beta x plus c2 sin beta x. Now let's look at these problems. Let's try to solve this one. And here we have y double prime plus y prime minus 6y. The first thing we have to look is whether we can factor this one or not. And if you see, this one is factorable, right? We can factor like r plus 3 and r minus 2, because when you multiply you have to get -6, and when you add you have to get 1. So this will work. And from this one we can see that r is equal to -3 and r is equal to 2. So we have two different distinct r1 and r2. So we are going to use the first one: y is equal to c1 e power r1x plus c2 e power r2x. Now let's go ahead and write that one. Y is equal to c1 e power r1 is this one. R1 is our -3. R2 is this one, minus 3x plus c2 e power 2x. So this is going to be the general solution for the first differential equation. Now let's go ahead and do the second one. The second one we have is y double prime minus 8y prime 16y. And if you look at this one, this is a perfect square trinomial. Like this is y minus 4 square actually, because you know that a square minus 2ab plus b square. So this is matching that pattern, right? Here we have 1 and 8, 16. Okay, now let's see. So this is going to give us r minus 4, right? So if we have this pattern, that's equal to a minus b square. Okay, so that's why we have r minus 4, r minus 4, and if you multiply this one 2 together, you will get this one back. Okay, but before I do that, I have to write the corresponding function. For this one also I have to do that, because if I directly do that, it might bring some confusions, right? Okay, so before I go ahead and write like this, I should write the corresponding function like r square plus r minus 6 is equal to 0. And after that we factor this one like this. And for this one, same thing. This one is equal to r square minus 8r plus 16 is equal to 0. Now you can see the perfect square trinomial pattern clearly, right? So r minus 4, if you multiply this one together, you will get this one back. So r minus 4 is equal to 0. Therefore, here also this is equal to 0. Therefore, r is equal to 4, and this is repeating twice. R is equal to 4. So here this is matching the second condition. When we have repeated single root, the general solution for the differential equation is going to be y is equal to c1 power e power rx plus c2 x e power rx. Now let's go ahead and write this one in that form. So this is going to be y is equal to c1 e power, our root is 4, so this is going to be 4x plus c2 x e power 4x. And this is going to be the general solution for the second differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.